I had a question about 9.3 number 5, which is using a fourth degree Taylor polynomial centered at x equals 0, so a Maclaurin series, to approximate the function at x equals 0.2. So if we're doing a fourth degree, we need to get 4 derivatives. So I'm going to take 4 derivatives first of my function. So I bring down the exponent. And then because of chain rule, I'm going to multiply by -1, and then this becomes positive 2. Take my second derivative, and it would be -6. And then times -1 because of the chain rule. And what I'm noticing is that these two negatives are just going to keep canceling out. So the next derivative would be 24. And the fourth derivative would be 24 times 5. Oh, that's really 5 factorial. Okay. So this is really 2 factorial. This is really 3 factorial. And this is really 4 factorial. So now I'm going to evaluate each of my derivatives at x equals 0. So f of 0 is 1. F prime of 0 is 2 factorial. Second derivative at 0 is 3 factorial. Third derivative at 0 is 4 factorial. And the fourth derivative at 0 is 5 factorial. Now I'm going to plug that. I need that light back there, Isla. Do you want to say hello? Not today. I know there's some next to the kitchen sink. Alright, so then if I write that fourth degree polynomial, it would look like this. It's going to be a fourth degree. The constant term would be 1. The linear term would be 2 factorial times x. The quadratic term would be 3 factorial divided by 2 factorial, x squared. The fourth degree term would be 4 factorial divided by 3 factorial. And then it would be 5 factorial divided by 4 factorial. And one nice thing about this is that stuff just winds up canceling beautifully, because like 5 factorial is 5 times 4 times 3 times 2 times 1. 4 factorial is 4 times 3 times 2 times 1. So really 5 factorial divided by 4 factorial is 5. So my fourth degree polynomial is really this. I'll be right there, Isla. And then the last step, we're going to use that polynomial to approximate the function at 0.2. So the last step would be to plug 0.2 into that polynomial. I would use a calculator for that part. All right. Thanks for asking. Good luck.